Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 10.4 on the inverse of a function. And we're going to ask the essential question, how are a function and its inverse related? So think about what we know about the word inverse already. When we talk about inverse of a number, talk about its reciprocal, right? So we multiply it together. So we have multiplicative inverses, which means we multiply them together, we get 1. We have additive inverses. We add them together, we get 0. So functions basically kind of undo each other, right? I mean, the inverses of a function, inverses are going to undo each other. So let's talk about, first of all, the relations. When we talk about relations, of course, we're talking about a set of ordered pairs. Relation is a set of ordered pairs. When a relation contains the ordered pair a comma b, then the inverse is b comma a. It doesn't get much simpler than that, right? It doesn't, because it's going to get harder than that right now. Not a lot. This is fairly straightforward. So that's about the relation of the x and y values in inverse functions. So the first thing you're asked to do here is find the inverse of each relation. And I'm not going to do all of these, but for negative 4, 7, well, that's going to be 7, negative 4. Pretty straightforward, isn't it? For negative 2, 4, well, that's going to be 4, negative 2. 0, 1, 1, 0, and so on. Let's talk about on a table. If the input's negative 1 and the output's 5, well, remember, input is x and output's y, so we're just going to reverse these here. So my new input here is going to be 5, and my output's going to be negative 1. From output of, for input of 0 and an output of 10, well, my new input's going to be 10, and my output's going to be 0. For input of 1 and an output of 15, my new input's 15, and my output is going to be 1, and so on. So you kind of see how those work. Those are inverse relations. And so writing the formula for the input of a function. So we have f of x equals 2x plus 1. Okay, so we're going to solve y equals f of x for x. So we're going to set this equal to y, and then we're going to solve for x. Oh, this is pretty straightforward. So if I subtract 1 from both sides, I'll have y minus 1 equals 2x. And then dividing both sides by 2, y minus 1 all over 2. Oops, what is that? All over 2, sorry, equals x. Okay, so this is my inverse function. And then find the input when the output is negative 3. Okay, so the output, they're referring to, of course, is the y. So negative 3 minus 1 over 2 equals x. Finding the input, negative 3 minus 1 is negative 4 over 2 equals x. So x equals negative 2. Okay, so that's an example of that, writing a formula for the input of a function, set it equal to y, then solve for x. Okay. Inverse functions, okay, so this is what I was alluding to earlier. This is a vocabulary term here. Inverse functions are functions that undo each other because an inverse function interchanges the input and output of the original function. The domain and range are also interchanged or switched. So it was the domain of the original function becomes the range of the new function, and what was the range of the original function becomes the domain of the new function, the inverse function. Okay, so let's get those vocabulary terms in our notes, and then we'll move on. So how to find the inverses of functions algebraically. Now, I did a little bit of this earlier, but you might want to get these steps into your notes. We'll set y equal to f of x. Okay, so if it says f of x as a function notation, we're going to set it equal to y. Then we're going to switch x and y in the equation. Okay, so we'll write a new equation where x and y are switched, and then we're going to solve the equation for y. Okay, so those are our 3 steps. So get those into your notes, pause this if you need to, and then let's take a look at writing the inverse of a linear function. Okay, so I have f of x equals 4x minus 9. So the first thing we want to do is rewrite it for y equals 4x minus 9. Then we're going to switch x and y in this equation. And then we're going to solve for y. So if I add 9 to both sides, I'll have x plus 9 equals 4y. And then dividing everything by 4, x plus 9 divided by 4 equals y. Okay, and I want to show you what these look like on the Desmos graphing calculator, just so you can kind of get an idea what what inverse functions look like on being graphed. So here we are. You'll see that the original function, that y equals 4x minus 9, is this kind of dusty red graph. The blue line is that inverse function that we calculated. So you'll notice that what was the x-intercept down here becomes the y-intercept of the new graph. And also, what was the y-intercept of the original graph, -9, becomes the x-intercept of the other one. And they're going to intersect at a point where the domain and range values are equal, 3, 3, because they undo each other, right? Okay, so that's what those look like. So let's go back and we're going to look at another type of function, the quadratic function. Okay, we're going to do the same thing here. I'm going to set this equal to y. So y equals x squared, and we're being constrained here that x has to be greater than 0. Okay, so x has to be greater than or equal to 0. So I'm going to switch these around here. So I'm going to say that x equals y squared. And then to solve for y, I take the square root of both sides, so y, and this is going to be plus or minus the square root of x. But because x has to be greater than or equal to 0, this is going to be a positive value. So this is just positive square root of x equals y. Okay, so let's take a look at what this looks like on Desmos. And one thing I want to talk to you about is how to put these in here. So the first thing we had was y equals x squared. Now we know how to put that in. How do we put in that domain? We're being constrained where x has to be greater than or equal to 0. So right after we put this in, using the curly brackets, we can say x has to be greater than or equal to 0. And then now the graph only appears in the to the right of the y-axis. Okay, so there's that one, and then the inverse function. If you think about it, what's the inverse operation to squaring something? And it is taking the square root of something. So we'll take the square root of x in this case, and there. And again, they're going to meet here at 1, 1 because they're opposite. They're going to intersect at a point where the domain and range are equal. So there's that one. Let's take a look at another one. But first, this horizontal line test. The inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than once. Okay, so it's kind of like the vertical line test, except because we're dealing with inverses, we're going to give it a horizontal line test. Okay, so let's look at the last type of function we're going to look at here is the radical function. Determine whether the inverse of f is a function, then find the inverse. So let's take a look at this. Let's just go ahead and do this here. So y equals square root of x plus 2. And I'm going to reverse the x and the y. I'm going to switch them. And now I'm going to solve for y. So I'm going to square both sides in this case. So this becomes y plus 2. And this becomes x squared. And solving for y, then x squared minus 2 equals y. So that basically makes this a quadratic. Now, let's talk about the domain and range here. Now, for this one, the range has to be, the original one, the range, because we're dealing with a square root function, the range has to be that y has to be greater than or equal to 0. That means in this new function, my domain is x is greater than or equal to 0. And let's go ahead and graph these two so we can take a look and see what these look like. Okay, so I put this in without that the part about the domain at the end. Now remember, it's because it's quadratic, we got two solutions and all. But again, we have to now say, using those curly brackets, that the domain here is x is greater than or equal to 0. So then you can see once again we have this this point here where they intersect at 2, 2. And what was the this is the original one. So I'm sorry, this is the original. What was the x-intercept becomes the, what was the y-intercept becomes the x-intercept of the other one. Okay. So again, they are inverse functions. Of course, negative 2, 0. So this is going to be 0, negative 2. All right. That's it for now. That's the end of chapter 10, at least as far as my videos go. He's got some other problems to look at in class, and then we have the chapter test probably at the end of the week. So I thank you for all your hard work, and I will see you in class next time. Bye-bye.